Alright, looks like we're live. Let's do another programming session. It's a live programming session, so you get to see the thought process, all my mistakes and everything else. We're working on integration with Spansh, and today we'll try to integrate with the bodies search, that'd be stellar bodies. And specifically, we are looking for planets that have rings, so that we can ask our AI assistant when we are out in the boonies to find us a system that has carrier fuel, tritium. So in Spansh there is a search, it's a third one down, bodies, and we want distance, we want reference coordinates, that's where we're starting from, we want reserve levels and ring signals, yes. So ring signals would be like tritium, but you can actually put anything you want. You want to put like a reasonable distance in there. No, let's say 1000 light years, and just for shits and giggles some data. If you right click, hit inspect, and bring up your inspector window and go to the network, you will see all the network traffic that's going between the site and the server. There is no API for Spansh such as it is, so we'll have to reverse engineer the calls. If you hit search, you'll see two requests. First one is post, and the post is going to spansh.co.uk API body search save. So that's what we're doing our initial request. The request looks like this. Show me the raw. Copy. Let's open up our little Scratch file here. Where is it? Scratch JSON. Right. So it's a JSON object that has a reference coordinates that I entered in. It's first page, number of results per page. I'm not quite sure what this count is, like 1 to 17. I guess I'll just mimic this in this comparison thingy. I'll leave it as it is. Distance, minimum, maximum, and ring signals name is tritium. So this is the thing that we are sending. And what we'll get back is this JSON. So let's look at the raw data, pretty print. We get all of this wonderful information, including rings that contain tritium. And somewhere here there's going to be a star system name and whatnot. So the idea is that we will ask our Copilot app to search for tritium, and this is the Java implementation of the client. But it's a proper true singleton. Singleton pattern as our two URLs, the HTTP client, the JSON factory, and it is very similar to the one that I did for the station. You'll see this is very similar. So I'll do 2 or 3 more integrations and see what the common code is, and then collapse this into a common code so there is no code repetition. But for now, I'll keep them separately. It'll be easier for me to figure out what is common, what is not, and how to construct a class that actually just represents a Spansh client that would work for. all, if not most, most if not all searches. Anyhow, see what it does. First, it takes to JSON convertible interface, which basically an interface of any object that we want to wrap into JSON, and it will implement to JSON, which returns a JSON string. We do the initial request, passing it our search criteria, converted to JSON. We get the response. From the response, we get a JSON object, and from the JSON object, we get the reference ID. That's our token. This token looks like the response. Nothing, which we will post to the headers. It's not a post, it's a get. It's a get to spansh.co.uk API body search recall this particular search, and if you know this URL, it will always return you that set of data. So we pass it back to Spansh. It's a to-call kind of thing, which then in turn returns us this information, the JSON information, which is a lot. And we pass it, this is where it's being called from, perform search, and we'll stick it back into the data transfer object. So basically we map in two data transfer objects. One is the request. It looks like this with, can I zoom in? Yes, of course I can. I'm on Linux, I can do everything. This is the Java mapping of the JSON fields, like the last time. Pretty much the same approach. And we've got our filters, we've got our sort that we are not actually using, we got the size, I'm defaulting this to 5, but you can pass whatever you want. Reference coordinates, that's where you're coming from. Then the filters, in our case we'll make a filter for the rings. The to JSON interface contract implementation. Here are the filters themselves. It has a list of signals, so you can search for more than one thing, like grandiderite, bromellite, tritium, whatever. You can put more than one. For now, we'll just pass one from a specific call. But technically, you can actually search for any kind of goodies. In the rings, problem will be with speech-to-text, because speech-to-text, unfortunately, stumbles when you say things like grandiderite. It will just say like grandy or something. It doesn't know grandiderites. Then coordinates, these be the coordinates that we are coming from. Zoom out. Zoom out. And then there is search DTO. Composition, filters, parent, that I suppose that be the parent body around which the rings are. Swirling. We'll see what the data looks like. Reference, reserve level. No, these are the result and the result. Still come as the results. Well, anyway, let's run this thing. Here in our mock test. Client search. Here's the actual search. You pass it the material you want. The reserve level, which in our case is, we can pass pristine, common, low, major, and depleted. Why would you want to pass depleted? I don't know, but maybe you do. And the galactic coordinates to get from the player session. And then we just basically fill up the criteria, construct our criteria, stick it to the search, run the code, and return the stellar object search result DTO. And this is how we call it. We get the instance of the stellar object search thingy. We call the method find rings. We tell it we want tritium, we want it pristine. The next thing we pass is the player session with marked coordinates. we're coming from and get the results. So let's stop in here, run this thing, make sure that it works, and if it doesn't, I guess we will debug it. Yes. Bam. Results. Let's look at what kind of results we've got. Zoom in just a sec. Zoom in. Windows key plus. There you go. That's how you zoom in Plasma. Points. So this is our first result object. It is that planet. So somewhere here there should be a star system. Reserve level pristine, which is what we asked for. System name, so that's the star that we'll be flying towards. And these are the rings. That planet has one ring. It is an icy ring. And signals, there are 6 signals. Alexandrite, bromellite, grandidiorite, low temp diamonds, with opals, and our precious carrier fuel right there. So that's what we're looking for. And zoom out. Yeah. So now we know that this thing works. We just need to wire it into the LLM and see if we can just issue a verbal command, find me some carrier fuel to mine, because I also have a command to actually buy it. Since we are way out in the boonies, you can't buy anything in here. It's pretty far to the nearest store. Okay, so let's do that. I don't know if I like this view. Appearance. Where's flat packages? Flatten packages. There we go. Used to this view. Look at the brain handlers. And that would be a command. Make a new command. Make a new handler. Creative moment brain fart. I need to figure out how to call it. Find area fuel mining site handler. How's that? Is that good enough? Yeah, let's do that for now. And what do we usually extend? Command operator and command handler. Yes, we do. Okay, implement the method. The name to signature. Implement the constructor. Oops, why am I typing in the wrong spot? We need it in here, so it's final. Private game controller. It's the game controller into constructor. It will be automatically injected through the magic of how this project is built. Game controller monitor and executor, and this the game controller. All right, so we're set. And now we just need basically we need this code right here from our test class that I'm going to delete. Bam. So this is our, these are our tritium locations. Oops. Tritium locations, get results. So these are our results, and we most likely just want to go for the first one. Results. First. We can collapse this into one line like this. And from the result, get, although on the other hand, if tritium location, if, we need to make sure that we found this. So if, for whatever reason, is empty, Get results is empty. And also, if for whatever reason this is null, then we're just going to say that no tritium locations found and returned from here without executing any further code. Otherwise, we are going to grab the star name. There's system name, and this is where we are going to navigate. Let's get our route plotter. And we will plot route to that location. Let's see if this much of it works, but first I need to actually define a command and be careful not to we don't have anything about carrier fuel. Cups. Find fleet carrier fuel mining site. Not to be confused with find fleet carrier fuel to buy at a local Walmart. Find fleet carrier fuel mining site. We don't pass anything. And that's it. Right? Okay, let's double check because I'm not picking the coordinates, do I? Yes, this is going to barf miserably. We need to get player session. And it's not new player session, it is player session, get instance, get galactic coordinates. So that is our current location. Which if I borked my session file, we might not have it. So I need to like kind of fly out and fly back in to reset my coordinates. Let's see. So this is the data that the app records. Current location ID 0. Go to locations. Location ID 0. What is it? It's a fleet carrier. Does it have coordinates? Yes, it does. So this is where we are at. Theoretically, this should work.
Systems online.
Find fleet carrier mining location. This is stupid. This is not gonna work. I said something really stupid. So where did it take me to? Which command did it execute? To use artificial intelligence, such as LLM, you first have to have natural intelligence, which obviously I do not possess. Plain fleet carrier mining location, yeah. Okay, all right, I borked that one.
Systems online.
Find where we can mine some fleet carrier fuel, please. Well, sort of kind of works.
Systems offline.
The problem is that it's way too far away from where we're at. Are there really no fleet? Are there no planets with rings in Spansh around where we're at? There can't be. I'm not. It's not far from. From civilization. So it kind of works, but it really doesn't. So I need to massage this. All right. So let's say I'll drop the. Actually, I can actually do the coordinates because I do have coordinates. Let's do it the right way. So locations. Location number 0. Let's just copy these coordinates right here into Spansh and see what we'll find. And debug and figure out where I went wrong. Okay. I assume this is XYZ and not ZYX or in any other combination. Yeah, there are some places like, how far is it? 440 light years. Copy to clipboard, go to game, enter this in here. It's much better. So I expect the results to be something like this. Rather. Pyroifoi. Pyroifoi. I don't know if that's the correct pronunciation, and frankly, I don't care, but it's supposed to take us to Pyroifoi. Why is it not taking us to Pyroifoi? So let's stop in here and see what's actually going on. Debug.
Systems online.
Find the location where we can mine some fleet carrier fuel, please. Alright, so these are the results we got. Actually, that's a result. No, okay, fine. Let's look at the result. Singular. That doesn't look right. Because that seems to be a bit too far away. B4 is the planet, so the system will be this. Yeah, it takes me like way over there. So why? Did I mess up coordinates? What are my galactic coordinates specifically? Alright, 4,659, 32, and 5,991. Is it the coordinates that I entered? Can I see the coordinates that I entered? Yes. Oh, and I didn't put the reserve level. Pristine. Search. Still is this Pyroifoi thingy. Okay. Disconcerting. Why is this happening? Let's see. Tritium locations. What other locations are there? Maybe I need to sort it. Probably need to sort it. So they gave me three locations. Oh, I mean, sorry, 10 locations. This is the one that is way too far away. I mean, the coordinates are like... It doesn't have coordinates here. Well, maybe it does, but they just buried somewhere. Yeah, that's like really not the sector I'm in. How odd. I honestly did not expect this behavior. What about the last one? None of them are even close. Well, Sinuefa, this is kind of like the closest one. Where is it? There. No. Okay, so I might need to order these by distance. Voice. This is closer to me. It seemed to be a very strange result. And the thing is that none of them match the one we got on the site. Maybe my request is wrong. Maybe I screwed up something in my request. Or distance. Maybe I didn't specify distance. Is that it? Did I not specify distance? Okay, distance, blah blah blah. Find rings. Oh yeah, I'm not passing distance, am I? I'm not passing distance criteria. Is it in criteria? Because I already forgot what it is. Or filters. Filters? Filters, that's set. Adding signals, resource levels. Alright, search criteria DTO. Does it have distance? No, it doesn't. That might be the problem. Okay, so let's do search and look at the request. Give it to me raw and wriggling. Copy this into, where's my scratch pad? I need to exit this. Yes, I know it is going to stop typing, bunch of shit. Stop it. There. Okay. Scratch. So distances and filters. I need to represent that inside of the filter. Filters. Sure do not have that. Okay. So, where's it? Serialized name distance. Private double distance. Why double? Int will do. Getter. No, not getter. I need getter. Better. Make me a setter. Oh no, distance would be a class because it's minimum maximum. Right. Distance is a class. Public. Static distance. What do we want? Min max. Look at that. It understands. And then filters, distance. Distance. Setter for distance. Here we are. Okay. Now, where is... suppose that will do as well. Blah, 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 blah. Get instance, find rings. So filters. Set distance. New distance object. There it is. Minimum 0. Maximum. Like last time, I'll hardcode it right now, and then we'll pass it as a parameter. Let's do 800 light years. All right, and we'll just test it from the test class by giving it these coordinates. Yes. No. Copy. And here. This coordinate. In there. Run this in debugger. Results. Let's see what we got in our results. Uh-huh. That's more like it. That's more like it. So this system right here is this one, which is 440 light years away from where we at. Isn't that beautiful? Yes, that's what we want. That is what we want. And this is in the first... That is in the first result. Now, results get results. A result, does it have distance? Inside result get distance. Yes, it does. Yes, it does. So results get results. Where is it? Oh, stop doing that. Stop it. Stick me a comparator in here. Thank you. Okay, so now theoretically we should have results sorted by distance before we even get them. And now let's test. Let's test it in the app.
Systems online.
Find us a location to mine fleet carrier fuel, please. Activate. Turn on the route announcements, please.
Congrats, you're the first here. Route announcements on.
Can we get fuel at our next stop?
Analyzing route telemetry, stand by. Crondor, no, next stop, Biowai. Your Golf Victor dash Mike Alpha 48 dash 0's a Y star, not scoopable.
Jump.
Hey count, cruising through hyperspace to Biowai Your Golf Victor dash Mike Alpha 48 dash 0. Y class star, warning, not a fuel star. Hey count, hyperspace jump successful. Traveled 70 light years to Biowai Your Golf Victor dash Mike Alpha 48 dash 0. Next stop Biowai Your Charlie Hotel dash November
Transition to hyperspace.
20 dash 0. Class M fuel star. One jump remaining. Congrats, you're the first here. Hey count, we're jumping through hyperspace to Biowai Your Charlie Hotel dash November, Bravo 20 dash Oscar, an M-class fuel star. Traffic and depths all 0. Hey count, hyperspace jump successful. Traveled 70.857 light years. Arrived at final destination, Biowai Your Charlie Hotel dash November, Bravo 20 dash 0. Was previously discovered, but not mapped.
Open local map, please. Optimize the approach speed, please.
Two was previously discovered, but not mapped. Two A was previously discovered but not mapped. 2 was previously discovered but not mapped. 2B was previously discovered but not mapped. 2C was previously discovered but not mapped. 2D was previously discovered but not mapped. New discovery, 2A ring. 2A ring was previously discovered, but not mapped. Hit count, surface scan complete, efficiency target met. Hit count, signals found, opal, tritium as carrier fuel source, and bromolite.
Alright, plot the route back to the fleet carrier, please.
Route set.
So, fleet carrier fuel confirmed. Great. Well, let's get out of here.
Sweet count keeps the carrier humming.
Enable streaming mode, please.
Streaming mode is on. Voice to text will still be processing, but I will not react to you. Please prefix your command with Word Computer.
Alright, so now...
Cruising through hyperspace en route to Beware Your Whiskey Charlie Delta Charlie 12-4, a K-class fuel star.
Computer, turn off the route announcements, please.
Jump successful, Krondor. Traveled 71 light years to Beware Your Whiskey Charlie Delta Charlie 12-4. Next stop, Beware Your Alpha India Bravo 27-9. M-class fuel star. 2 jumps remaining to Beware Your Mike Alpha Whiskey Bravo 29-9. Congrats, you're the first here. Route announcements off.
So now we'll augment the code and introduce distance, so we can ask, like within range, find us some carrier fuel within 1000 light years. Change it to that. As soon as we get back to the carrier, that is.
Congrats, you're the first here.
Computer, transition to hyperspace.
Frameshift drive charging.
Almost home.
Welcome home to Lone Wolf Count. Systems offline.
Okay, so the next thing is to pass the distance. Or range, rather. And we'll grab range like we're doing here, same way. and say the default would be within 1000 light years. The next one is, yeah, that's searching for the carrier fuel mining site within range get int range int value. Yes. And the next thing we want int range. Pass it in here. And then comma range get value. Oh, hang on. Why am I not?
That's an affirmative. See you soon, Commander.
I thought it would park me unattended while I'm looking at the code. And apparently that didn't happen. Okay.
Landing complete. Enjoy your stay. How can we help, Commander?
Systems online. I am listening.
Find us a place to mine fleet carrier fuel within 800 light years.
Searching for carrier fuel mining site within 800. Stand by.
Voila.
Systems offline. Say again?
Right. So that much of it works. Now we have a route plotter for the fleet carrier fuel. If you're way out in the boonies and you are running low on tritium, you can just ask your co-pilot to find you a mining spot and it will find it. Cool. Search for tritium mining spots. Now this can be extended, of course, to find any kind of material. It's pronouncing that so that speech-to-text actually understands. That will probably require training a dictionary, because it will figure out low-temperature diamonds, but something like bromellite, grandidiorite, and etc., alexandrite, it will fail miserably and it won't be able to pick it up. So if I do that, I'll have to spend some time figuring out the intricacies of speech-to-text shenanigans and then stick a lot of data into the dictionary file. It's this thing. Because, like, for instance, it does not understand tritium. You say tritium, it will translate it as 3-2, 3TM, 3-tube, 3-tube, 3GM, 3TM, 2 mine, and so on, and so on, and so forth. So these are all different mistakes that speech-to-text misunderstands, because it's not trained on fancy words like tritium. I mean, you can ask a Google Gemini what's isotope of hydrogen and it will tell you, but when you say word tritium, it gets absolutely sulky. And let's commit. Oops, I already committed a branch, didn't I? Yes, I have. Wrong shortcut. Get out of here. Get out of here. Commit this to the repo. Merge this to master. Let's go back to the master branch. Grab the sponge star object. Merge sponge object into master and push. Hang on. Switch tune to something else. Alrighty, now let's issue a tag for it. Remote build. Today is November the 17th, the year of our Lord 2025. Build. Oops. 011 phone. New tag. And this out to be our tag. Open terminal. SH. Remote build. Points. Okay, so it should fire the build in GitHub. Actions. Yes, there it is. Alrighty, good. This is all the time I had today. Have to run. But another feature implemented, and I will dig through other things that we can do with Spansh to make this piece of software a bit more useful. Thank you for hanging out. See you next time.